Chapter 6, Section 4 is about standard form of a linear equation. So by the end of this lesson, you should be able to graph equations using intercepts, and you should be able to write equations in standard form. So the slope-intercept form is just one form of a linear equation, and remember that is y equals mx plus b. And in this equation, remember the m always stood for slope, and the b always stood for the y-intercept. And using those two things, we could graph it. Now, standard form is just as useful, except it looks like this. ax plus by equals c. Now, this time, a, b, and c don't have meanings like m and b do up here for y equals mx plus b. But they can help us find the intercepts. So remember back to looking at a graph. This is the y-axis. We know that any point on this line right here means that x has to equal 0. So when you have a y-intercept, that means that you know x has to equal 0. And now we're going to use the x-intercept. So anytime something crosses this line right here, we know the opposite is true, that y equals 0. So what we're going to do is just plug these two things in. It's super easy to plug in something for 0, and then it's very easy to solve. We're going to do that using something called the cover-up method. So when you have an equation in standard form like this one right here, 3x minus 4y equals 12. Your x and your y are on the same side, and then they equal a number. What you're going to do is starting to write out coordinates for the intercepts, because remember, we only need 2 points to make a line. So this one right here where x is 0, this is going to be our y-intercept. And this one right here where y equals 0 is going to be our x-intercept. So to find the y-intercept, remember that means x equals 0. So cover it up. Just totally cover up that term. And then you have something really easy to solve. Negative 4y equals 12 can be solved in just one step, and we end up with y equals negative 3. So that's what they used right there. That is a point. 0, negative 3 is our first point. And if you look, that crosses the y-axis. Now the next thing we're going to do is find the x-intercept. But this time, we're going to make y equal to 0. So to do that, when you plug in 0 back up here, that makes this whole thing disappear. And all you have is this equation, 3x equals 12. So again, really easy to solve. We get the x is 4. That's what we have over here. That's another point. And because we have 2 points, we can connect the dots and make our lines. So let's just find the x and y-intercepts of this equation here. We're not going to graph this first one. So my x-intercept. Remember, if something crosses the x-axis, that means y equals 0. So what I'm going to do is plug in 0 for y. And that cover-up method that we just wrote down reminds us that if you plug in 0 for something, this just totally disappears. So we have this equation, 3x equals 8. And then all we have to do is divide by 3. So we get x equals, and we'll just leave it 8/3. This is a point right here. I know that when x is 8/3, y has to be 0. So that's one of my points, one of my intercepts. Now we can do the exact same thing, but this time find the y-intercept. And remember, if you're looking for the y-intercept, that means that x has to be 0. So I'm going to plug it in. And remember, the cover-up method reminds us that that just totally disappears, and we get this nice, easy equation. But all I have to do is divide by 4 on both sides. So y equals 2. And again, that's another point. When x is 0, y is 2. That's my other intercept. So now we're going to do this exact same thing, but this time we're going to put those points on a graph. So problem number 2. If I want to graph 2x plus 3y equals 12, I only need to find 2 points. So let's first find the x-intercept. So remember, that means y equals 0. So that means when I rewrite this, this totally disappears, and all that I have left is this equation that I can do in my head. X is 6. So this is a point right here. X is 6, y is 0. So I'm going to go over 6, up 0, there's a point. Now let's do the same thing, but let's find the y-intercept. So again, that means x equals 0. Plug it in. When you plug in 0, magically disappears. If I divide both sides by 3, I end up with 4. So here's another point. X equals 0, y equals 4. Alright, there. And then all it takes is 2 points to make a line. I connect the dots. Well, there we go. So the other thing you're going to have to do is take something that looks like y equals mx plus b and turn it into standard form. And in order to do that, we need to remember something we learned back in Chapter 3 on clearing fractions. So this says write this in standard form using integers. That means no fractions. So the standard form part tells us that we need to get x and y on the same side of the equal sign. So we got two things to do. Get x and y on the same side and get rid of the fractions. So when I look at this first one that they gave us, getting rid of the fractions is always my first priority because that's going to make my whole problem look a lot better. So I go to all of my denominators. This is 1, this is 1, and this is 4. So the smallest number that they all fit into is 4. So what I'm going to do is multiply everybody in my equation by 4. This is clearing the fractions. So 4 times y gives me 4y. 3/4 x times 4 just gives me 3x, because these cross off. And then 2 times 4 gives me 8. Now this equation looks a whole lot easier to deal with, and then all I have to do is get my x's and y's on the same side. So I'm going to move these 3 x's over here. I get negative 3x plus 4y equals 8. And that's it. This is now in standard form. So let's do one more together. So if I start with this equation, first thing I want to do is get rid of the fraction, because I know standard form can't have any fractions. So I look at all my denominators. I only have 1, and the smallest number that fit into them is 5. So if I multiply everything by 5, I end up with this nice, pretty equation. And then all I have to do is move my x's over to the other side. And then we tend to write the x's first, just because that's what standard form looks like. And that's it. One more problem. So let's say the sophomore class is holding a car wash to raise money. A local merchant donates all the supplies. And then they charge $5 per car and $6.50 per van or truck. Define a variable for the number of cars. So we don't know something, let's make it x. Define a different variable for the number of vans or trucks. Remember, standard form looks like ax plus by equals c. So we've already used up x, let's use up y. So then write an equation in standard form to relate the number of cars and vans they have to wash in order to raise $800. So the cars, I know that each car is going to cost $5. So 5 times the number of cars. And then I know each van or truck is going to cost me $6.50. So I'm going to multiply $6.50 times y. And then we're going to add these two things together in order to equal the $800 that they want to raise. So you should be able to graph equations using intercepts. So graph both of those problems on this graph over here. And then you should be able to write equations in standard form. You should definitely be able to do 27 and 30 and give 33 a try. It's just a little different. Make sure you write down any questions you have and we can go over them in class